Hey folks, welcome back to another episode of JavaScript Jabber. I am let me try that again. I am so sorry. I am so, I don't know. Anyway. Hey folks, welcome back to another episode of the Ruby Rogues podcast. This week on our panel we have Ayush and Nwatia.
Hello, hello.
I'm Charles Max Wood from Top End Devs, RubyGeniuses.com. We have a special guest this week. That is Stephen Margheim. Stephen, welcome back.
Yes, thank you for having me again.
Yeah, we had you on. I need to go look exactly when, but we had you on. We talked about SQLite last time, and I think it was mostly can you really do all this stuff in SQLite? And the answer was pretty much yeah. So, yeah, is there anything else that you want to bring up as far as an introduction before we dive in and start talking about even more SQLite awesomeness?
No, not much. I'm happy to be back here, just braving the cold, dark Berlin winters. So happy to have the opportunity to chat with some other Ruby and Rails enthusiasts, and hopefully, maybe by the end of this talk, convert you into SQLite enthusiasts as well. Let's see.
Awesome. So, yeah, let me get the link into the comments for the videos, but yeah, we talked quite a bit about SQLite last time. Are there any new developments as things go along with SQLite, or?
Yeah, so there's been one major development. So if I were to summarize the conversation last time, it would be, can we really do this with SQLite in a web application built with Rails? And the answer is yes, but you need to finesse it. Mm-hmm. And the big change, which is really exciting, is that the release of Rails 8 marks the first time that Rails, and as far as I'm aware, any major web application framework, has provided a fully production-ready experience for a server-driven web application backed entirely by SQLite. You can drive your cache through SQLite, your background jobs through SQLite, your WebSocket messages, obviously your primary data, and you don't have to fiddle with any configuration. You don't have to futz about with any setup or installation. You get a no compromises, high performant, but incredibly lean, mean, and stable application when you run Rails new. You literally can run Rails new and Kamal deploy, and you won't have any business logic, so it might not be very useful, but the bones of that application are as sturdy and as simple as they have ever been in the 2-decade history of Rails.
That's awesome. I have to admit that a lot of the stuff that's in Rails 8 that just kind of comes baked in, I am so excited about. On Friday, I was, how do I put it? I did some therapeutic coding in Anger. And I thought, okay, I'm just going to pull together this application. I mean, admittedly, I use PostgreSQL, but I literally, I did the exact steps you were talking about. Other than that, and I had to deploy an accessory on Kamal for the database, but then I only had one other accessory to deploy, and that was my Rails app. I mean, that was it, and it's so refreshing to be able to do that. And then I was looking at search, and I was thinking, do I have to do Elasticsearch? And it turns out that I am figuring out how to do the vector search in Postgres. So even that's awesome. And I think there's a vector extension for SQLite, isn't there? So
yes, there is.
I mean, this is the beautiful thing, right? And so if you want to deploy it and make it run and all of that stuff, you definitely can. I have a question just to throw that out there. You said you can just do the Kamal deploy. Do you set up an accessory for SQLite, or do you just store it on a volume so that when you kill and restart your Docker, it just connects to the same SQLite file.
The latter.
That's awesome. So then you only need one container.
Yes, exactly.
That's the coolest part about SQLite, I think. It's literally just a file. You're literally reading a file. I love that.
Yep.
Just a quick question about like the changes from Rails 7 to 8, which kind of made SQLite production ready. One thing that I know is something called a busy handler that was, I think, baked into the connection now. And there was a couple of other bits and bobs. I remember reading a long blog post from you. So could you just summarize what are the changes from Rails 7 to 8 that now make SQLite production ready that wasn't the case earlier?
Yeah, so there are two foundational changes that take Rails from being you can sort of use it, but you need to work around some pain points to it works out of the box. So the first one concerns how SQLite's transaction management system works in the context of a multi-threaded web application. So I'm going to try to do this as succinctly as possible, but the default way that SQLite works with transactions, it calls working with deferred transactions. So to give one piece of context, SQLite only allows one writer to be doing a write operation at a time. So it has linear writes. Now, you can open up multiple connections to the database, and you can have connections reading in parallel. Like that's totally fine. You can have 5 connections and they're all doing reads and they can just do that at the same time. But if you have 5 connections open and they all try to write, they have to line up and go one at a time. And when you use a transaction, the default behavior, so if you just write begin transaction, some SQL commands, and then commit, SQLite doesn't attempt to acquire the write lock. This is the way in which it figures out which connection is able to write. Like there's a lock and each connection has to pass it around. So it doesn't attempt to acquire the write lock until it sees a write operation inside of your transaction. So if you do begin transaction, select star, update set from select, at that third operation, it will say, okay, let me try to acquire the write lock. And the problem that you hit, and this is where anybody who tried to use SQLite in a Rails application before Rails 8, 100% saw this error in their logs. Database is locked. You got that error all the time. And that error was happening so often because when you begin the transaction, that is when SQLite takes a snapshot of your database to use for that transaction, right? To keep the isolation guarantee. And so when you have a write operation inside of that transaction, in order to ensure that isolation guarantee, right, for our acidic guarantees of this relational database, SQLite does not allow that attempt to acquire the write lock to retry. So you get one shot. If the write lock is being held by another connection, you immediately error. And so when you have a multi-threaded web app and you have many writes, there's no retry mechanism. It's like you either are able, it's the lock is free and you can grab it, or it isn't and you error. And so the first change was to ensure that when Rails generates transactions for SQLite, it explicitly makes them what SQLite calls immediate transactions. And all that means is that you attempt to acquire the write lock at the begin transaction statement, not at the update statement. And the begin transaction statement is when you capture the snapshot. And so if the lock is being held, then we retry the begin transaction. So we retry taking a snapshot. And it's not until we can acquire the write lock for that particular connection that we begin the transaction. And then we have the write lock for the entirety of the transaction. Everything will be fine. And we pass it along. So That immediately solved the major problem of just like getting a ton of databases locked errors by allowing our connection pool to deal with transactions. The second problem crept up thereafter, which is, okay, now when you are retrying, so retries are happening at the SQLite level, and they're happening often in our multi-threaded Rails application with decent write throughput. How does SQLite retry stuff? And it uses a very simple mechanism. Connection A has the write lock. Connection B attempts to acquire it, can't. SQLite says, okay, just sleep for 1 millisecond and then try again. So it sleeps 1 millisecond, tries again. It's still being held by A. So B is told, sleep for 2 milliseconds and try again. And it has a kind of polynomial back off.
It sounds like my kids. Dad, 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 Dad.
Are we there yet? Are we there yet? Are we there yet?
And then they sit there and listen for a second. No, he's in there. Dad, right? That's the back off.
Exactly. And this is simple and it works incredibly well, right? Like you can serialize concurrent operations like without the application needing to do any custom logic. That's great.
Right.
The problem
that's when I eventually go, what?
Yeah, exactly. The problem came from how Ruby and SQLite work together.
Okay.
Because the magic and the beauty of SQLite is that it is an embedded database. It's not a client-server database. And this means that it runs inside of your application process. You don't spin up a SQLite process that's running next to your Rails server process. It is code that's executed inside of that process. And what that meant for Rails, or Ruby more generally, is that by default, the way that Ruby is integrating with SQLite, the Ruby interpreter did not see SQLite's connection sleeping as I/O that it can release the GVL on. So the GVL gets retained as SQLite retries. And so what that meant was, if you spin up 10 Puma workers and one Puma worker acquires the write lock and it's doing a little bit of longer running work, another Puma worker could and should theoretically be able to do Ruby work while SQLite is doing SQLite work, but they weren't able to coordinate correctly. So this is the busy handler thing. So what we did
I'm just going to back up for a second because you mentioned the GVL.
Yeah.
Which is something that we've talked about at length on this show before, but not for quite a while. So the GVL is the global VM lock. And it says essentially, hey, I've got this thread that's trying to do a thing. And what Ruby does is when it's doing I/O, right? So if it's sending off to the network and waiting for a response, or talking to the database and waiting for a response, what it does is it releases the GVL and lets something else, another thread, pick things up and work. And so what Stephen's talking about is essentially Ruby didn't detect this as I/O, is what he said, which meant that it wouldn't release the GVL. In other words, it's going to sit there and it's just going to go, I'm still waiting, instead of, letting another thread pick up work and go do work. Because if it's not doing I/O work that it has to wait for, then it can do other things, right? It can calculate stuff or, sort your arrays or whatever, right? Because that all happens in the VM. And so, so what Stephen's talking about is you would have things essentially just hang there until they got an answer.
Yeah. And this is particularly important for typical Rails applications, because your typical Rails application is using Puma. Puma is going to spin up n number of worker threads. Let's just say it's 10. Mm-hmm. And the way that it is expected to work is that you are increasing your throughput by having high saturated concurrent work. So one Ruby thread can take an incoming HTTP request and do Ruby work to parse the string, get a sense, let me get the Rails request object. And then it makes a call to the database. And it's okay, now that worker is going to wait for the database. So the next worker over can start and pick up the next request. And so your CPU can be doing work constantly. We can really saturate our resources, take advantage of all of our cores and do high throughput work by really leaning into concurrency. That's like essential to how Puma is performant. And you could imagine that if talking to your database did not give the opportunity to your other Puma workers to do the other parts of the web request processing, you have 10 workers, but effectively you have one. Like you have removed the advantages of the concurrency. And so what we needed to do was, instead of using SQLite's built-in mechanism for retrying, we wrote, they expose a lower level API to write your own. And then that allowed us to write our own in Ruby. And so instead of calling the OS level sleep, we're calling Ruby sleep. And Ruby sleep does properly communicate to the interpreter, hey, I am just sleeping. That is IO. You can release the GVL. And the third related thing, just to finish off the triad, is when we were doing that rewrite and writing it in Ruby, I was doing benchmarking, and I saw that SQLite's implementation had a sort of subtle, nasty side effect that I call punishing older queries or older connections, where because it was a polynomial backoff, and it's just like telling you, don't ask me again for another 5 seconds. If you had high write throughput, once a connection needed to retry 2 or 3 times, so now it's waiting 5 milliseconds and then 10 milliseconds. New connections have a much higher likelihood of acquiring the lock because they will retry immediately and then 1 millisecond, then 2 milliseconds. So they get to try 4 times before my older connection even checks in again. And so if I have a steady stream of new connections, that old connection will go from the 4th generation to the 5th to the 6th, and you'll always have one which goes until it errors out. And so your like P99 will have like these big spikes because you'll have like one connection that just never acquires. So we also rewrote the logic to just have every connection every time check in every millisecond. So there's no penalty for being quote unquote older, having more retries as compared to younger, having fewer retries. And this flattened out the latency that we saw at like P99 and P95. So those 3 fixes are the major changes in the Rails 8 release that make Rails production ready out of the box. You're not going to get these database lock errors. You're not going to see these latency spikes in your P95 or your P99 statistics. You're going to get a high performance, stable experience by running Rails new.
Awesome. So I have another question. I seem to remember seeing somewhere that you were fairly involved in a lot of this. So when SQLite exposed the lower level thing, was that for Rails? Like, did you or David or somebody else go and actually talk to him and say, hey, we have this problem, can you let us do this other thing? Or was that something that was already there?
That was something that was already there. This is one of the things I have come to really appreciate about SQLite. It's 30 years old at this point, and it's used everywhere. And so it really is today like very feature rich and very powerful. The big difference that trips people up, because it's quite uncommon in our modern software culture, is that SQLite cares far more about backwards compatibility than it does about enabling newer, better defaults and features. And so what that means is that if you don't do anything, if you don't do any configuration or any tuning, when you are using SQLite today, you are effectively using SQLite as it existed in 2004, which is when version 3 was released. And so these myths and sort of fears that have grown up in the web development community, like SQLite is not a production-ready database, have a root in reality, because in 2006, SQLite was not a good database for web applications. It was squarely built for embedded devices in that context. Mm-hmm. Over the last 2 decades, a lot of features and a lot of work has been done to make it a far more flexible and powerful database engine. But literally, none of those features are enabled by default. You have to manually configure SQLite to be properly run in a web application. This is the other big thing that Rails does. We started doing this in Rails 7.2, but it has a set of 6 or 8 configurations that it applies to every connection you make, so that it ensures that SQLite is running in a web application friendly mode. So this is just one of many features that SQLite has had and sort of added over the last 2 decades that you can take advantage of to make SQLite run really well in the context of a multi-threaded web application. But you have to do the work to figure out how you need SQLite to behave for your context.
Is it
it's interesting
to just,
that you
summarize the connection parameters, or is that going down a deep rabbit hole, the configuration stuff?
I can summarize the key points. So the first most important one is that the original implementation of SQLite's journal mode, so the way in which it deals with stashing data to keep durability guarantees, was limited in that it required any operation to be linear. So reads and writes both contended with each other. So you could only do one thing at a time. So you could open multiple connections, but it was kind of useless. You were single-threaded, quote unquote, at the point of view of SQLite. Over the years, they added a new journaling mode, write-ahead logging, which is the same sort of algorithm that Postgres uses, which allows for concurrent reads. So that's like major change number one. You need to be in write-ahead logging mode. When you use write-ahead logging mode, you have a much naturally safer environment. And so if you don't care about like the absolute strictest durability constraints, you can flush to disk less often and get much faster performance. So the other default, like by default SQLite, after every write flushes to disk. So you're doing the file system calls on every write, which adds a lot of overhead. So Rails also defaults to flushing to disk less often, which is encouraged when you're using write-ahead logging, so you get better performance. It also expands the default size of the in-memory portion, sort of space that SQLite uses. This is another misconception people have, right? Like every database is working with data on disk. Like that's how we get durability for the ACID guarantee. But no database exclusively uses data on disk. Every database generates a pool of memory. It's like, here's a memory space I'm going to use. And they keep all of the hot data in that pool of memory such that they can just read and write directly in memory. SQLite does the same, and you can control how big that space is. And its default from 10 years ago is paltry compared to the memory that modern machines have. So we bumped that up. So for a lot of databases, you can actually like run your entire database effectively in memory. Like there's literally no way any database can beat the speed of SQLite in that context. That's actually what the guys at Wafris found. They ported their client from using Redis to SQLite. He messaged me at one point. He's like, hey, I think I'm doing something wrong because I ran these benchmarks. And it's actually faster with SQLite. And we're switched to SQLite because we need like richer query language. And we just knew we were going to pay that with slower speeds, but somehow it's faster. What am I doing wrong in my benchmarks? And we dug into it. It's like, no, your whole data fits in memory. So SQLite is A, more expressive, and B, faster than Redis in this case. And then we do a few other like small little bits and bobs. I have a whole blog post on my blog that breaks down all of the different settings with links to the documentation and explanations. Just the last one I'll flag here. Rails has been doing this forever, though. You have to manually, by default, SQLite does not enforce foreign keys. So like originally when it was built, foreign key constraints were just like syntax, just sugar. The engine didn't do anything with them. They added that feature later for backwards compatibility. It's not added by default. So you have to explicitly say, SQLite, please enforce my foreign keys.
Interesting.
What's the title of the blog post that you referred to?
Let me look up the exact title. So my blog is at fractalmind.github.io, and I have a little search up at the top. So I'm going to search for pragmas, which is the name. I think it's called fine-tuning your database.
Cool, I can see it now. I shall dive into that later.
Yeah, I need to. I just want to capture it too, so that we can put it into the show notes and the.
So let's move on to something a bit more Rails specific. So the solid trifecta, which I am quite excited about because it's like more stuff baked into Rails rather than reaching for third-party dependencies. It was obviously kind of conceptualized with SQLite in mind, which is awesome, but there's still quite a lot of Postgres out there in the world. So my question is, how, like when you think about web applications, how differently do you have to think when you're using SQLite? And if you're using the solid trifecta with Postgres, are there any things you really need to be aware of? Because instantly things like solid cable, where you're kind of polling for messages, it's making my spidey sense tingle that this is less efficient than Redis. But is that a misconception when it comes to Postgres? Because in SQLite, I know you can poll that much, it'll be fine.
Yeah, so there are differences. The short answer is yes. Like, I think that your spidey sense there is on to something, right? So let's start with action cable. So Rails has had a Postgres-specific action cable adapter for a while now. And that adapter uses Postgres's inbuilt listen notify functionality, which is faster. It's more performant. It will scale more naturally as your throughput increases. But it does come with a trade-off of like a maximum message size of, I think, like 8 kilobytes. There's a gem that expands that max size. And if I were using Postgres and I wanted to like keep everything simple, like not bring in Redis just for that use, I would 100% use the action cable Postgres adapter and not solid cable. That is better tuned to that architecture. Now, if I'm all in on MySQL already and I don't want to bring in the Redis dependency just yet, and I know that I don't have like a ton of WebSocket traffic, right? Like I'm just doing a few basic things, pushing down alerts when background jobs finishes. And it's like, I only got 6 background jobs, stuff like it's going to be totally fine. But you should go into it being aware that you are going to have some different pain points. The biggest one being that, of course, when you're dealing with a client-server architecture, your primary bottleneck is the network latency. Like every database is fast, really fast. Like databases are really magical pieces of technology.
I want to just interject. So not 2024, but 2023, when David or DHH gave his keynote talk, he talked a lot about why the databases are faster how the disks have gotten faster. And, you were talking about memory capacity. That's another thing that's expanded, and you've alluded to that. So I love all of the allusions to, modern computing and just what the capabilities are. But anyway, go ahead.
Yeah. And so you are penalized in a client server architecture for making a large number of small queries. And this is one of the biggest mindset shifts you need to make if you want to embrace SQLite, because it's really deep in Rails developers' like limbic system, right? I want to prefer a small number of large queries. But when you're working with SQLite, you actually want to flip that. You are going to get a better performance profile by having a large number of small queries. And so that's like one consideration. And so if we think about something like Action Cable, the nature of Action Cable is like, you can't aggregate those queries, right? Like if you're just doing the polling, you're just making that get. Well, I'm using an HTTP verb there, but we're making that read.
That select, yeah.
And you have to eat the network latency. You just have to. So for something like Solid Cable, it's really well tuned to SQLite, the way that SQLite is built. And the fact that we isolate it in a separate database means you don't even have to worry about concurrency. Of course, if Basecamp were to use this, they would experience very real pain, because now polling for Action Cable messages is contending with serving all of their other application database needs, right? So if they just use a single big beefy MySQL instance and they're doing all of their application reading and writing as well as this WebSocket polling, now their connection pool, the resources of that instance are all being used up for both of these use cases. And so you do need to be more thoughtful, especially if you're unsure about how your usage might scale over time. If you're using something like Postgres and MySQL, especially around Action Cable. For something like the cache, I actually think that there are real advantages to using a database-backed cache, regardless of the database engine you are using. At the scale of Basecamp, they, through experience, and they talk about this in their Rails World talks from last year, introducing Solid Cache, came to see, that contention is too high. So they split out a separate MySQL database for their cache. And that, I think, is going to be the case at really sort of any decent size for your cache. But the point that they make, which is when you just massively expand the size of your cache, right? I can just keep way more things in the cache, and I can keep them in the cache for longer. Then your cache becomes more useful because you just have more hits naturally. There's more things to hit against. And that's what the database offers you. And because of modern computing, because the file systems are faster, the RAM is faster, the networks are faster, the difference that you have between even some of your cache hits, needing to go to disk to fetch the data to send it back, is much smaller than it used to be. So I would recommend looking at Solid Cache for any application, regardless of the database engine you're using. For Solid Q, if you are all in on Postgres, this is another case where honestly, probably Good Job is a better fit. It's explicitly tuned to Postgres and using its features. The really nice thing that makes Solid Q quite competitive is that it has more useful features out of the box, like recurring jobs. That's just there. And they have done a ton of work to make it super performant on Postgres and MySQL. Obviously, Basecamp and 37 Signals use MySQL, and they are using Solid Q in production, doing tens of millions of jobs. So it's totally production ready at really large scales as well. So I would also feel very comfortable using Solid Q with MySQL or Postgres at larger use cases. But in general, all three of these gems like lean on polling, and SQLite's just the best sort of perfect fit if you want to use a database engine and you just want to poll all the time, because those reads are effectively free. I mean, they're so fast and there's really no contention or penalty. So it's like, yeah, just poll all the time. Like you basically have real time. There's not a ton of complexity and there's not really a ton of trade-offs.
So one thing that I'm wondering then is, because I just switched over to SolidQ, and it has a plugin that like you fire up Puma and it runs all your so everything just runs on the same server essentially, right? You just tell it run the server and it runs the server, it runs the workers, and it does everything. So what you're telling me is if I'm still really in love with PostgreSQL, I can do that for all of my, I guess, primary level data. And then for the queue and the cache and the cable stuff, I can still use SQLite and just avoid all of that network latency on these tiny polling queries. Is that what I'm hearing?
Yeah. So if you just run Rails new with defaults, you're going to get SQLite everything. You're going to get all the solid gems. And the way that it'll be structured is that Rails will create 4 different database files.
Mm-hmm.
It'll create we'll just talk about development, a development.SQLite 3, a cache, a queue, and a cable.SQLite 3. So
yeah,
4 different files.
I told mine that I was using Postgres, and it still created the other 3 with SQLite, I believe.
Yeah, that might be true. I honestly haven't spent a ton of time initializing Rails applications with anything about Postgres, right. So I don't know those details as well. But so what that means is that so SQLite has this constraint of linear writes, but that constraint is at the file level. So you can write to your primary database, add a job to the queue, add a message to the backlog for cable messages, and add a cache entry in parallel. You can do all 4 of those operations at exactly the same time.
Right.
So there's no contention across the different services, and all 3 of those additional services will run directly inside of Puma if they need a separate process like SolidQ does. And so you don't have to set anything up, and you don't need anything more than that one single machine. So like I build and deploy my applications on Hatchbox on a single DigitalOcean droplet. Mm-hmm. And I have I had the big first app that I really went all in on SQLite with and led to a lot of these additions to Rails is still running in production, and it is on a $20 a month droplet. And that app has made multiple millions of dollars in revenue in the last 4 years. It's really kind of beautiful how cheap you can run these applications like this. Like this is a targeted B2B application that just isn't going to have ever more than 1,000 concurrent users. And so I don't need a huge box. I don't need to run a whole bunch of things. I was a single dev. I built it and maintained it for years. It was super straightforward, lean, easy to operate, easy to deploy, easy to evolve, super fast for those kinds of applications. So I think like particularly B2B applications are like a great fit. Like you have a certain kind, you typically have a sort of geographic boundary, right? Like you're building a business in the UK, you're mostly going to have UK customers. You're building a business in Europe, you'll mostly have European customers. You're building a business in the US, you'll mostly have US customers. You're going totally virally successful means like maybe you have 10,000 customers, right? Like it's just totally different than trying to build the next TikTok. SQLite and vertical scaling are such high leverage decisions for those kinds of businesses. You can operate your business so efficiently and add so many high-powered features to your application so quickly and so cheaply. That's where I get like particularly passionate. It's just like that more people appreciate that, yeah, objectively, Postgres is a great database. I have nothing negative to say about it. But the idea that it is the only viable option for a database in 2025 in production is objectively laughable. SQLite and MySQL and Postgres are all really great databases that there are very legitimate use cases for in 2025.
Yeah, that's it's quite a pitch, and I'm not surprised to hear that from you with how passionately you've been kind of waving this flag for the last couple of years. And I'm giving SQLite a go on a side project I've got just started. So looking forward to diving into that. How do you feel about the architecture that Chuck briefly mentioned, where your primary database is Postgres, but you're using SQLite for jobs and caching and solid cable or whatever? How do you feel about that kind of architecture?
I think that it makes sense and can work, especially if you have an existing application and you like want to start exploring some of these things. I think that solid cache driven by SQLite is a really great place to start. Like take an existing application, leave your Postgres Heroku. Well, not on Heroku. SQLite doesn't work on Heroku. So not on Heroku. If you're using Heroku, just use Redis and Postgres and you'll be fine.
Yeah.
But in a context where you're not using Heroku, just like spin up a cache database with SQLite. It can get really huge, not going to have any problems. There's zero need or reason to go all in on one immediately. It's totally fine to mix and match. For me, one of the primary benefits of SQLite is the opportunity to have a maximally operationally simple application. So for me, I start all new applications going all in on SQLite because it's like, I don't want to run two machines. I don't want to figure out how to secure and network two machines. I don't want to, okay, I'll just do one machine. And it's like, let me make sure I'm running the two processes. Let me make sure I'm doing that resiliently. Like what happens if my Postgres process goes down? How do I have my app process handle that gracefully? I need to have another process running that watches the Postgres process to bring it back up when it goes down. Like it gets a little bit out of hand rather quickly. But if you have an existing application, this is not in any way an all or nothing. I think cache is a great place to start. Cable can also be a good place to start, though if you're already on Postgres, the Action Cable Postgres adapters, I would start there. You still don't have to reach for Redis. But yeah, mixing and matching is one of the core philosophies of Rails, right? This is omakase at its best. So I do embrace it and encourage it, particularly for migrations, but I will beat the dead horse once again. If you're starting something, if you're running Rails new, like just give it 1 month. Give it 1 month. Just try it for 1 month. That's all I ask. And if you say, you know what, I just really, really love Postgres, awesome. Go use Postgres. But if more devs just tried, I think we would see a real change in the makeup of Rails applications in production, because there are very real benefits for bootstrap businesses to lean on this technology.
So I got a couple of questions here. One is you've talked about some of the optimizations that you can use in Postgres, whether you're enforcing foreign keys or, some of the other pragmas that you can turn on to kind of tune your database. And it sounded like Rails does some of this for you. You can correct me if I'm wrong there. But I guess that's my question is, do I effectively get all the goodies for free, or do I have to go in and set up SQLite and or Rails in a particular way to get any, to optimize for whatever I'm doing with it?
You get all of the essential goodies for free. For having a production-ready experience on day one, all of that is by default. You don't have to touch anything. But like with most of Rails, you have levers available to you. So, for example, there are dozens of SQLite pragmas. You can configure all kinds of things about how SQLite runs. The database YAML file accepts a pragma's key, and you pass a nested hash. Mm-hmm. And you can just set whatever pragmas you want in your database YAML. So that's built into Rails now. So you can add configuration, you can override configuration. If you're like, hey, I'm looking at my VPS, I know the services I'm running on it, I can commit way more memory to my SQLite database. I know I have 4. I know I'm going to do 5 connections each. I know I've got this much RAM. I know all the other services. Like, let's give every single connection like 1 gig. I'm on a big beefy server. Let's give them all 1 gig. Overwrite that. I'm huge memory addresses for every connection. You can do that. But there is not a single required action that you need to take. You can literally run Rails new and put it on a production server, and everything will be good. So it's just write your business logic. But you can do extra things. So you can also pull in, I have a gem to provide access to the SQLite extension ecosystem and make that easy to bring into your application. So you can bring in SQLite extensions like the vector search extension, and integrate that into your application very easily. Doing backups, that's not something that is like a Rails default, but there is a gem to do that easily. So if you really take it seriously, like if I was building a business, there are a few extra steps that I would take, but that's true of every Rails application, right? Like there's like the Rails plus subset of like gems that everyone turns to really solidify an application for showtime. But the core fundamentals with Rails 8, every single essential detail is packaged into Rails new and requires no additional work to get a production-ready experience.
Makes sense. The other question I have is, I'm trying to think through some of the apps that I'm either built or I'm building or things like that. And one of them, you mentioned that, I guess I'm worried about workload, right? And I know that we've talked in the past about, hey, it can get, you can get pretty large workload, but let's say I do hit some kind of limitation, right? I don't know how likely that is, but let's say that I do hit some kind of limitation. So I want to shard my database, or, maybe I want to break it up by tenant because I'm doing a multi-tenant database or something like that, or a multi-tenant app. How hard is it to do that kind of a thing, and how likely am I to even need to consider it?
Yeah, I'm going to start with the second question first. So the team at 37 Signals did a lot of different load testing for the Campfire application. Mm-hmm. And the Campfire application uses SQLite for the primary database and Redis for all of the accessories. This is because they built it in Rails 7.1 days, and it's harder to, all the solid gems didn't exist, and there's various reasons. But I took that code base, swapped out all the Redis for SQLite, ran my own benchmarks, and everything was at least as fast, if not faster. In their benchmarking, in a chat application, using the primary chat, sending messages and getting the responses back. So write heavy, right? Not like a typical 80-20 read write.
Right.
When they benchmarked their beefiest server in their benchmark, you can go and find their posts to get the details of that machine. I don't recall at the top of my head. They supported 50,000 concurrent chat participants.
Wow.
So imagine that's basically like a 50-50 read-write split, and that's 50,000. So you go 80-20, you can get to 100,000 concurrent users, I'm 100% confident an application can support 100,000 concurrent users on SQLite. So I want to be very clear about like where the limit is, because like I understand it. I have the impulse to. I had the impulse for a long time. It's like, but like maybe, just maybe, I'm building the next Facebook, and then what am I going to do if I have like 1 billion users? It's like, okay, yes, but I promise you aren't. Like I can mathematically guarantee you're not going to win the lottery, and you're not building the next Facebook. And the odds of your application having 100,000 concurrent users is astronomical. So just that's step one, to really state very clearly, you aren't going to hit a performance limit. You won't. Now, that being said, let's imagine you did accidentally build the next Facebook on top of a SQLite on Rails application.
I'm working on it.
What would you do then? Well, I think that sharding is indeed like the natural place to go. And if you will permit me a bit of gentle teasing, I happen to know that there is a project underway right now that will make the SQLite sharding story much better. Right now, it would be a fair bit of manual futzing about to get it set up right. And at some point in 2025, this project will be released and it will be way simpler. So as long as you don't become the next Facebook, as long as you don't have more than 100,000 concurrent users in an 80/20 read-write CRUD application before the end of 2025, you have nothing to worry about, because it will become really straightforward to shard to the level of giving every individual tenant of your application their own SQLite database. So the sky really is the limit, and by the end of 2025, I think there will basically be no performance problems, aside from hitting the bottleneck of I have vertically scaled to the biggest possible machine that exists, and I still have too much traffic. Like I'm Facebook going from 1 billion to 2 billion people now, and now I need to horizontally shard my application. But there are a number of tools in that space. They're all necessarily younger than tools in the Postgres and MySQL space, and that were like built in that world from day one. But they do exist. They are getting more and more battle tested each year. So there is a story available to you to horizontally shard, whether that's using libsql, which now has a Ruby adapter and an active record adapter, whether that is waiting for the Limbo project, which the Terso team, they are basically rewriting SQLite in Rust with async built in from the ground up, waiting for that to fully come to maturity, whether it's using LiteFS to get console-driven cluster, multi-node cluster management for SQLite databases. There are a number of tools here in this space, all sort of maturing at their own sort of pace with their own communities. So there is a story to be told for horizontal sharding as well. So short summary of the answer, you aren't going to hit computational limits on SQLite. Statistically, I can say that almost with a guarantee. If you did, there are paths available to you, whether that is sharding your database so that you can deal with more write throughput and you can get a beefy server, and that beefy server will handle your users just fine. Or you go supernova and you have 1 million concurrent users and you start horizontally sharding your application, and you pick up a tool like LiteFS and bring a distributed SQLite architecture into the mix. There are tools and communities and solutions on all of these points that are present and open source and available to us all. So there really is not an actual ceiling.
So one thing where I would still be a little reticent, and you can tell me if I'm wrong, and this is not necessarily for my own projects, because I completely get where you're coming from, that I'm not going to be building the next Facebook. But if you're using SQLite, then I think, would I be right in saying that scheduled downtime is something you kind of need to just accept if you're making big changes? Because like 100% uptime is not a thing, but if you need to be as close to that as you can possibly be, when you kind of need to do blue-green deploys, where bringing another server up, making sure it's accepting requests, and then taking the old one down just so you make sure you don't go down. That kind of system is not great for SQLite. Would I be right in saying that?
A little bit, not quite in the generic way that you said, but you're getting to a core point. So at the generic point, like I use Hatchbox from all of my apps. Hatchbox uses the old Capistrano style deployment where you just add another directory to the releases directory, and your Rails server process is running, and you just swap out the symlink. And that 100% works. Like I have 0 downtime deployments. I've not, it's not like, oh, I'm deploying, I have to bring it down for 5 minutes. So that is totally fine. When you embrace vertical scaling, if your machine dies and you need to recover, then yeah, you have downtime because your machine went down and you need to recover. So it's not so much around deployment as it is around disaster recovery, where you will have downtime. But that's much more a factor of embracing vertical scaling than it is a factor of SQLite. Though, if you embrace SQLite, I recommend you embrace vertical scaling as well.
When you say vertical scaling, you're saying you add memory, add disk.
Yeah. You run your application
on a bigger machine and you run everything there.
You're getting a bigger box as you need it. Yeah. Exactly. But on the deployment front, it is worth being explicit about the fact that if you have a old, successful application with SQLite that has some very large tables, and you make certain kinds of schema migrations to those tables, you're going to have some pain, because if your migration requires making writes, the migration writes contend with the application writes. SQLite only allows one write operation at a time. And the way that we typically write these migrations, they're very, very greedy. So they will tend to beat out your application writes. And so your application will suffer and very likely experience some form of downtime. So there are migration situations in which the simplest way to avoid any angry pain from customers is to do scheduled downtime. But that situation is doing writes against a very large table. And by very large, I mean like over 1 million rows, let's say, which of course is not crazy to get to, but
adding an index or calculating a value on a new column for every row.
Yeah. So adding an index would be the most common one. Supplying like a new default value, backfilling data to a column that you added, work like that. Yeah, exactly. So it's a little bit more nuanced, but it is true that vertical scaling means if you need 5 nines of uptime, you don't. I should start there. Like if you need 5 nines of uptime, you have been sold marketing from AWS that is a lie. Literally, AWS is the only service that needs 5 nines of uptime, and they lie in order to keep it. So even AWS doesn't have 5 nines of uptime. It doesn't exist, so you don't really need it. But let's say you actually truly need 3 nines of uptime. If that is essential to your business, I would not recommend a vertical scaling approach. I would recommend going in the complete opposite direction and distributing your compute and your persistent data to the edge. and really recognizing like for you to be successful in your business, you're going to need to solve the distributed systems problem. I will make the note, though, that SQLite is particularly good if you need to push compute and data to the edge. It's not going to help you any if you put one big Postgres server in Virginia and you put 10 application instances in every continent. In fact, it's going to kill you because you're going to make one HTTP, your customers will make one HTTP request from their laptop to your service, which is right next to them. And then your application will make probably on average 10 HTTP requests to your server for all the different queries. And it would have been much better for your customer to make one long network request to Virginia, and then your application be right next to the database and do 10 really short queries than the opposite way around. But if you're going to the edge, you have computational constraints. And it's kind of really perfect, actually, to just have a file on disk. And so just as one example, we can find the blog post and add it to the show notes. There was a company that's doing authentication as a service. They're called OSO. And as a part of their business success, they're like, A, we need 3 nines of uptime. And B, because our customers will be hitting our API for every one of their customers' web requests, our P95 needs to be 10 milliseconds. So how do we do that? Like, well, the only way that we do that is we put 10 application instances around the globe. So we just have to do distributed service. So then the question becomes, well, how do we do that? Well, obviously, I don't want to put one database in Virginia. That'll destroy my P. There's no way I have a P95 of 10 milliseconds.
You can't make that round trip that fast, right?
And you're going to make 10 of them. So I have to put my data right next to my application. Now I'm going to have 10 instances of my application. So what is going to allow me to have all of the sort of data access patterns I need for my application, but will work in the constrained environment of the edge instances I'm using? SQLite will be great. So then how do I solve the problem of distributed SQLite? They did a homegrown solution. So they build on top of Kafka. And so they distribute the SQLite data and get to eventual consistency across all of their instances through Kafka. So anyway, all that to say, I really think that the world is moving towards the edges, and that the sanest thing to do moving forward is to either fully embrace vertical scaling, right? It's like, I'm building a business in Germany for Germans. I just need the one server in Frankfurt, and it's going to be great. Or embracing the other extreme and saying, like, I'm building a global business. I'm going to have customers that are as valuable to me in Japan and in Sao Paulo. And so I just need a fully distributed thing. And I think that SQLite is fairly uniquely positioned with the set of trade-offs and value propositions that it makes to be a really solid choice in those two extreme scenarios. And Postgres and MySQL were really well positioned for the middle case, where you're trying to have as much of both as you can. But my sense is that the world is moving away from the middle case, and embracing the edges and the extremes is going to be likely a better business decision. And so really thinking about the kind of application you're building and what kind of architecture makes most sense. But SQLite is kind of weirdly perfect at the extremes.
Nice. I have one last burning question regarding database backups. And I know, if I remember correctly, the last time you were on the show, it was before my time, but I remember watching the video. I think you deleted a production SQLite database by accident, if I recall correctly. I think with SQLite, it's easier to do that than with any other database system, because it's just a file and you can quite easily delete it. I know Lightstream is a thing, but let's say you're me and allergic to dependencies, because I hate putting stuff in my gem file. And I want to do it. I'm like, it's just a file. All I need to do is make copies of this file to do backups. I'm sure I can write something myself. What's the recommended way to do SQLite backups? You just copy paste the file out, or is there some kind of native thing to do backups?
The fancy utility CP.
Exactly. So I just provided a link here in our little chat. We can add it to the show notes as well. But one of the other great SQLite enthusiasts in the Ruby community, Old Mo, as he goes by on GitHub and Twitter.
Oh, he's awesome.
Yeah, we've had him on the show. He's really great.
Yeah,
so he has a great
name, but
blog post on different backup strategies for SQLite, and he really covers them very thoroughly. But just to hit you with a few things. So SQLite comes with 3 different backup strategies. You can call backup. You can call dump. These are slightly different. They also have like the SQL command vacuum into. So he breaks down those differences. I won't retread all of that right now. But indeed, genuinely, you can call CP. And one of the points he makes, which is, I will reiterate here, is that most production Linux servers are running file systems that have copy on write functionality available. And so if you do CP with the option reflink always, you get actually like a really, really fast, very, very space efficient backup of your database. And then, of course, you do have something like Lightstream. So the benefit of Lightstream is that you can get really fine-grained backup. So you get point-in-time recovery. But it does come at the cost of you have to pay for the S3 compatible bucket storage service that you're going to use, pay for that storage. You have to run another process, so the Lightstream process, to copy over the data. If you don't need like resolution to the second level for backups and you just want to set up a cron job, you absolutely can use one of the other 4 methods. And his blog post really breaks down the pros and cons, like which ones are more space efficient, which ones have faster restore performance, what's the complexity to use them, what's the level of durability that you get. So I would just read through that article and think about like your use cases. But if you don't want to bring in a dependency, whether at the file system or at the SQLite level, you have 4 different options for generating a backup that have different pros and cons around durability, restoration speed, and space efficiency.
Yeah, for me, the thing that I'm concerned about, and granted, when my first job out of college, I was working for an online backup company, right? It back up all of your pictures of your kids to the cloud kind of thing. And so I'm imagining, if a meteor hits the data center and I want to deploy it somewhere else, then I need that file in the cloud somewhere. I guess I could just have it on my local machine, but anyway, I need it somewhere that's not the data center. And so that's what I'm imagining. But yeah, I mean, this gets me a file that I can push to the cloud. So do you just, I guess I'm wondering what those options are. Do you just extract the file as long as you have whatever time granularity you like and then figure out how to get it up into AWS?
Yeah. So if you just wanted to use one of these sort of simpler built-in services and you want different levels of durability, the basics that you have is like, let me put it somewhere else on this machine. Mm-hmm. So it's in a totally different directory. So the way in which I accidentally deleted my directory, there was a feature in Hatchbox, which has been changed, by the way, where in the web UI, you can rename an application. And so I was just futzing about. It's like, I'm going to standardize all my applications because I'm OCD. Not clinically, I should say. That's a colloquialism. But so I just changed the name of the application. And the way in which they pushed that change to the server is they ran rmrf on the application directory and then ran a new deploy. And so the fact that my SQLite directory lived in the shared subdirectory did not help me at all. So I could have a backup to just some other place that's not likely to be accidentally rmrf. But then it's like, well, if my machine goes down, that's not so great. So I want to put it somewhere else. You can use network attached storage now. Like all of these services provide volume storage. True. So the other thing you can do is you just CP it onto the volume storage. So now it's on a different machine, but it's in the same data center. So if the data center goes down, it's not so great. So then you could set up a third layer to pick up those files and put them on some other service, right? You could just set up Backblaze probably on those Linux machines, however you wanted to do that. Or you could also you're like, well, I really want the durability. Then I would embrace the dependency of Lightstream. Like it's a really low overhead dependency. And so now you can get your backups, A, fine-grained, but most importantly, B, in a completely other service, in a completely other data center that has no relationship to your application service, data center, or machine. But generally, that's like the layers of durability that you have available to you. And you can, however far you want to go for your use cases, you can work your way out without a ton of effort.
Cool.
Gotcha.
We've spoken quite a lot today about like you won't need this, like you don't need 3 nines of uptime and stuff. So from my point of view, when I was thinking about this for one of my own projects, I was like, all I need is a Hetzner box with an attached volume, and I'll just write backups to the attached volume. Now, of course, it's the same data center. But for my small scale, I think that's fine. Like, would you agree with that?
Yeah, I mean, so for most things, I think that the trade-off for if everything goes to shit, everything has gone to shit, right? It's like just presuming things don't go to shit and not take it's the old adage that it's the last 20% to finish something that takes 90% of the time. That really is true. And most services do not require the level of resiliency that would take the next 90% of effort. And so just saying like, how actually critical is this? And so for anything where I'm not trying to make money, it's like, it exists until it doesn't.
Right.
And so I'm not going to put a ton of extra time and effort and money. For things that are trying to make money, then you do need some durability because like you have to keep making money if something bad happens. But that's basically it. That has been my own rule of thumb. So every single non-money making application I have, I don't do fancy Lightstream backups. For all of those applications, I actually don't do any backups, to be honest with you, because I know the one way in which it failed. And I talked with Chris Oliver and he changed it. And so unless I manually go in there and RMRF, like my data's fine, it's all set up correctly. So I don't even run CP or anything. For anything else, I personally just jump to Lightstream, but like network attached storage with CP, great. It's a nice middle ground.
So is Lightstream a paid service or is it just?
No, it's an open source utility. You have to pay. So it pipes your data to some bucket storage service like S3, R2, DigitalOcean Spaces.
You have to pay for that.
So you have to pay for that storage, but the tool itself is a MIT open source utility.
Awesome. One other thing I just want to throw in, because we've mentioned it a few times now. I did a quick Google search on like how many minutes or how many hours of downtime per year is 5 nines. So 5 nines is about 6 minutes of downtime per year. And yeah, I mean, nobody's going to notice, I think, if it's 6 hours, which 3 nines is about 8 3/4 hours per year. So, if you have an outage here and an outage there, right, for 15 minutes or 20 minutes, you're going to be well over the 3 nines and you're going to be fine.
Yeah. And I think the other key point that I like to preach on is that there is a massive difference to the health and sustainability of your business between scheduled and unscheduled downtime.
Right. True.
Scheduled downtime is a beautiful, simple, powerful tool in your business's tool belt. It is not very difficult to communicate to your users in a way that makes them feel respected and appreciated to take 30 minutes of downtime to deal with a complicated database migration or to vertically scale your single machine up to a bigger instance.
Mm-hmm.
And so I feel like we sort of, in a lot of ways, the conversation around web development has gotten to a place where we have sort of simplified things and we just talk about downtime as if it's all the same. And it isn't. And attempting to, again, like swallow all of the complexity to have a system that theoretically never, ever, ever goes down is a really deep rabbit hole of complexity. And we can win back so much time and so much mental space if we just accept the leverage available to us to say, I am going to control when my application goes down. And it's true, like a vast majority of applications have really regular usage patterns. And as a part of their usage pattern, have multiple hours where no one is using the application. Like you have time available to you to just like go down and literally no one will ever notice. And even if you have people using it all the time, like you're going to have low periods and you can just let people know, hey, I'm going to be down for 30 minutes 2 weeks from now and everything will be fine. Like you can continue making money.
Yeah. Well, it also, in my opinion, I mean, you know, I don't remember if it was you or Ayush that brought up 5 nines, but the diminishing returns, right? I mean, because you go from 6 minutes to almost an hour for 4 nines. It's just you're optimizing away just a tiny bit of unplanned outage, and you know, I don't know. I feel what you're saying there. Yeah, if you know that you might cause it, then you just let people know, hey, you know, we're doing a scheduled maintenance, and hey, maybe you get lucky and your index doesn't take more than a few minutes to build anyway, but just letting people know it might be slow or go down. Yeah, you get a ton of grace out of that. One other thing I wanted to ask you about. So the word is that you're building a course, or you've built a course about some of this stuff. Do you want to tell us about that?
Yeah. So you might have been able to tell, but I'm pretty passionate about the general concept of giving individuals, giving small teams leverage. And I personally think that Rails 8 and SQLite, when paired together, are a really powerful lever for making things on the internet. And so I partnered with the internet's favorite dad, Aaron Francis, and I recorded at the end of last year about 60 video course called High Leverage Rails. So you can find it at highleveragerrails.com, and it will be coming out in a couple of weeks. And it is a course to walk you through everything that you need to know, but nothing you don't. So try to keep it as like lean and focused as possible to build applications with Rails and SQLite. So we walk through like an introductory sort of module on like, all right, active record in SQLite. What is really happening here under the hood? Feel comfortable with how SQLite is working and sort of some of these differences around preferring a larger number of small queries to a small number of large queries. And then we just start building a simple application to go through all of the details, like to really understand what is solid queue, what is solid cable, what is solid cache, how are they set up with SQLite, what are the trade-offs, what are we doing? So we step through the whole process of building a basic application, focusing on giving people the knowledge and the tools and the confidence for them to then go and do this themselves. And we go all the way to shipping it to production. So we use Hatchbox is the tool that I use most and think is perfectly well suited to SQLite on Rails applications. And Chris at GoRails has actually sponsored the course, which is exciting. So from Rails new to running in production, we build a whole host of different features to really exercise all of the sort of functionality available to us in a Rails application. So we set up jobs, we have a cache, we send action cable messages, we do JSON, some fancy JSON stuff. We do full text search. We take advantage of SQLite's full text search engine, dig into all these different details. I think it's going to be a really excellent resource, particularly for people who are interested in a lot of these kinds of philosophies I've been harping on here on this call around, like, I want to find leverage. I want to generate value. I want to move fast, but I care about quality. I care about understanding what I'm doing, right? Like, sure, AI can help you move really fast, but in 2 months when you need to make a change or there's a bug and you're wading through the mountain of slop that makes no sense to you and you really don't know any of these tools, you're going to be in for a world of pain. So really, I really want to push this idea that you can just master 2 very approachable, simple tools, right? It's super easy to get started. It's straightforward to really genuinely master these tools. And then you have the world at your fingertips, because not only can you move fast, can you leverage AI with tools that have been around for decades, right? Like all of these AIs have been trained with like millions and millions and millions of tokens on these topics, these tools. But you can be a true craftsman. You can have full control over what you're doing such that your system and your business can evolve over time without you feeling anxious about like what the hell's going on. So this middle ground of like finding your leverage, mastering your tools, but still moving fast, being responsive and adaptive to the market, I think this is my sense for like where the future of the sort of web economy is going. And this is my attempt to sort of help as many people as possible to get their foot in the door and start making noise on the internet for the betterment of us all.
Awesome. So where do you get the course?
Yep, check it out at highleveragerrails.com. You can sign up for the waitlist. We're going to have a early bird discount, so get on the waitlist. Planned release is February 18th. All the videos have been recorded. We've done the first pass of editing, so we're just doing a final pass of editing right now. So I expect that it'll come out on February 18th. And if you are on the waitlist, you get a nice discount. So highleveragerrails.com, check it out. And I look forward to hearing everyone's feedback.
Awesome. All right. Well, I was going to go to picks, but you mentioned that you're going to be speaking at some conferences in April before the show. So do you want to just let people know where those are too, and then we'll do our picks?
Yeah, I literally just before the show found out the third one. So in 3 straight weeks in April, I'm going to be bouncing from Sao Paulo, Brazil, where I'll be speaking at Tropical on Rails, then hopping back over the ocean to Poland to speak at Wrocław RB. And then the week after that, I have to fly over to Japan. I'll be at Ruby Kaigi this year and speaking there. So 3 straight weeks, 3 different continents. It's going to be a fun and hectic month.
Awesome. Well, yeah, if you are going to be at any of those conferences, definitely look for Stephen. Let's go ahead and do some picks. Ayush, do you have some picks?
Yeah, I do. It's funny. Last week, I was so distracted for about half this podcast because I broke production for my client. And when
you didn't delete the database, did you?
I didn't delete the database, just causing some nil errors. Aren't those the best? And I did a pick for my app, which I relaunched called scattergun.email, and I neglected to say what it was about, what it actually does. So I'm just going to go ahead and re-pick scattergun.email, which is a mailing list platform with a focus on privacy and simplicity. So it's like my take on stuff like MailChimp, but without all the extra marketing stuff. It's like literally all you want to do is drop a subscription box on your website and then email that list. That's kind of what Scattergun does. So you can just drop a web component into your website to collect email addresses, and then Scattergun will give you an email alias and just fire up your favorite email editor and send an email to that alias. My app will receive it. It'll tack on an unsubscribe link at the bottom and send it out to your list. That's literally all it does, to be honest. It's fairly simple. It's always going to be fairly simple. It's never going to have fancy marketing features, but if that's the kind of thing that you fancy, then give that a go. So I've done the proper sales pitch this time, so I'm going to leave that to the side for the next picks. Because last time I was just like, after I got off the call, I was like, I mentioned it and then I forgot to say what it actually did. Yeah, that's what breaking production will do to your brain. And I'm going to do a couple of picks. I'll do a music pick. So I think I might have mentioned them on this podcast before, but I love a band called Solstice. They're a really grassroots level band here in the UK, and they do kind of folk kind of music mixed with rock, mixed with progressive rock, weird shit. They've got a new album coming out in a couple of months, and I've got early access to it. And I got it 2 days ago, and I've had it on loop pretty much ever since. There's a track on there called Twin Peaks. Is the most hauntingly moving piece of music I've heard in many, many years. So if that sounds even vaguely interesting, maybe go check out their last album, which was Light Up. And their upcoming album is called Clan, which will be out in early April, I believe. And I've been going for quite a lot of comedy gigs in the last week. So there's a comedian called Rob Orton, who I really like. He's got a YouTube, an older special of his on YouTube for free. So if you like weird stand-up comedy, then go check out Rob Orton, The Time Show. It's on YouTube for free. So yeah, those are my picks.
Awesome. I'm going to throw out a few picks here. So I've gotten really deep into the launch for Ruby Geniuses and JavaScript Geniuses. So just to give you a quick rundown on those, and then I'll do my board game pick and stuff like that. And I'll try not to be too long-winded. When I got into programming and the times where I felt like I was really progressing, I had a handful of things really going for me. I had meetups that I could go to and people I could talk to at the meetups. I had a mentor that I was working with at the time. I was watching Rails casts. Anyway, there are a bunch of things that I wanted. We kind of did book clubs. I got some mentorship from the guys I was doing Ruby Rogues with way back in the day. There were conferences and anyway, so what I'm looking to provide to people is that kind of experience, because a lot of these things have kind of gone away, or I've just kind of advanced to the point where I'm not working with anybody who really pushes me on tech or anything, Ruby or anything like that. And so, I get a certain level of that from this show, because we're talking to Stephen. Stephen knows way more about SQLite and some of this stuff than I do, right? So I can ask him all my questions. But what I wanted to do was just put together this system. And so I'm scheduling meetups right now. We'll do a meetup every week. One of the meetups every month is going to be something about AI, because that seems to be where people are at. And then I'm going to be putting out videos on how to do stuff primarily with Rails. Like I said, I'm also doing this on the JavaScript end, and so that'll probably focus more on React. Yeah, we're going to have a place where you can come and chat. There are going to be premium podcast episodes, and you'll get discounts to any of the summits that I put out. So last year I did a summit on just where Ruby was headed. And so this year I'm looking at doing some more of that stuff probably in the summer. And you'll also get discounts on retreats. I want to start doing retreats where, we kind of get like a big giant Airbnb that has a room that can hold 20 or 30 people. and invite, a handful of people. So, maybe Stephen or maybe Ayush, or, if we can get Uncle Bob Martin or DHH or Aaron Patterson or some of these folks that you all know, right? And so we all get into a room and just talk about how we can program better, but you kind of get that FaceTime with somebody who's, I guess, sort of at that higher level of access, and also, somebody that you want to sit and pick their brain. So anyway, that's the deal. You can go to rubygeniuses.com and sign up. I've also been sending out emails to my email list. I signed up for the system I'm using before I knew about Scattergun. Sorry, Ayush.
Don't worry.
But anyway, so just go to rubygeniuses.com. If you sign up before Valentine's Day, February 14th, I'm also throwing in a 1-hour coaching session, and my coaching rate's about $200 an hour. And so that's a $200 value right there. And then the other thing I'm throwing in is either over WhatsApp or something similar. I'm offering text and voice coaching. So you'll send me a message. Hey, I got stuck doing this, right? And then I'll get back to you and say, okay, this is how I would do it. Or, these are the things that I would look at, or, whatever, right? Anywhere up and down the chain from performance to how do I do this particular thing. And if I don't have the answer, the nice thing is I've been doing things like Ruby Rogues long enough to where I probably know somebody who knows the answer. And so I should be able to track it down. So anyway, that's what we're putting together with rubygeniuses.com. You can sign up for a month, you can sign up for a year, or you can sign up forever. Those are the prices. So go to the website, check that out. And I'm super excited to be collaborating with people. I did leave off, we're going to be doing a monthly book club as well. So we're going to be picking up something like Pragmatic Programmers, or
my book.
Yeah, or your book. We might do that, right? And so then it's, you show up. So you've read the book, probably worked through it. And then, we show up, usually the author's there, because I know a lot of them too, and we'll do that. So that's all part of the deal. Some of them might be combined with the JavaScript group if the book is more generic programming. But I'm not going to shy away from picking, a solid Ruby book or a solid JavaScript book for the other group. And we'll probably do both of those in the same month so that we can have separate meetings. But anyway, that's what we're pulling together. People are looking to connect. A lot of times people find jobs through these things. There's going to be some level of career growth, job hunt content to it, just because I've talked to a whole bunch of people who are looking for that. But that's what we're putting together. So rubygeniuses.com. Now, as far as board games go, I'm trying to remember. I think last week. No, I don't think I did pick it last week, so I'll pick it this week. I played a game with my friends. So one of my friends is teaching the hot games at SaltCon, which is a conference in March in Layton, Utah, it's north of Salt Lake, where you show up and you play games with people. I went last year. I'm probably not going to be able to go this year. But anyway, he's teaching the game, so he's trying to learn the games. And we played a game last week called Cascadero. And Cascadero is you're effectively placing little horsemen, and they're carrying word about the new king's ascension to the throne. Not that that has any bearing on anything. It's just kind of the premise of the game. And then, so when you place your piece next to a city, then if it's part of a group, so if it's your second piece in the group or higher, then you get to move up the progress track. And as you move up the progress track, you get points, and you win at the end of the game if you have the most points and you've gotten your color of your marker all the way to the end of the board. Board Game Geek weights it at 2.53. I liked it. I don't know if I would go buy it, but I did like it. It was fun. I kind of want to play it again just because some of the mechanics were a little bit odd to pick up, and now that I understand them, right, I'd like to play it again and see if I can do better. It says it's ages 14 plus. The community says 10 plus can play it. That's probably fair. We played with 3 players. It's 2 to 4 players. And anyway, it was kind of a fun game. It's done. It's made by what's his name? Rainer Knizia. I'm sure I'm destroying his name. I think he's German or something. But anyway, he's done a bunch of other games that you've probably played if you're in the board game area. So another one that I picked was Mlem. Anyway, he's put out dozens and dozens of games. And so Lost Cities, I think I've picked on here before. So anyway, go check it out. I'll put a link into Board Game Geek where they have that rating. And then I'll also put a link in for Amazon so you can go buy it on my affiliate, which doesn't cost you anymore, but I get a kickback if you use my link. So anyway, I've gone on way longer than I wanted to, so I will let Stephen do some picks.
Yeah, so my first pick, a little bit of a, I don't know, play, I guess, on the word, but my first pick is going to be the city of Philadelphia. And there are 2 reasons why. The first reason is that I am picking the Philadelphia Eagles to become Super Bowl champions this Sunday in Super Bowl 59. Just for a quick bit of context, born and raised in Louisiana, but lived in Philadelphia for about 8 years before I moved to Berlin 6 years ago. And I just can't, I don't know how anybody lives in Philadelphia and doesn't become an Eagles fan. It is, I think they put something in the water. So I'm a big Eagles fan. But the second reason that Philadelphia is my pick is that I am super excited for RailsConf this year. For anyone who doesn't know, this is the final RailsConf. Ruby Central has been putting on RailsConf for over a decade now. I don't even know how many years. And they have decided to focus their efforts on a single conference each year. And so this year they are doing RailsConf, but not RubyConf. And then moving forward, they will only be doing RubyConf. And so the very last RailsConf ever is being hosted in Philadelphia, Pennsylvania, which will be the only time that a Ruby Central conference has ever been in Philadelphia. I know the hotel that the conference is happening at. I know the area where the conference is happening. There's like really great food options, really great experience. It's going to be an absolute blast. I am really looking forward to that. The call for papers just opened up, and that's going to be open for all of February. I recommend everyone to take the time to sit down and gather your thoughts and try to present a interesting, cogent narrative for something that you have thought about or done recently. Like, all of us have done interesting things. All of us have had interesting experiences. And there is so much value in even just preparing a proposal, let alone you getting it accepted and then preparing a talk and getting involved in that side of the conference experience. So big year for Philadelphia. Let's go Eagles. And hopefully I'm not too sad on Monday. But that's going to be my first pick. Just for a technology-related pick, I have been using a couple of gems from my friend and collaborator in the open source world, Joel Draper, for some of my more recent projects. And I just want to shout them out because I've really enjoyed using them. So 2 in particular. For those who don't know, Joel Draper is the creator of Flex. Flex is the Vue library in Ruby that allows you to write HTML with pure Ruby. So no templating, string templating syntax, ERB, you just write normal Ruby. That's a great project, but he also has a library called Literal, which we're going to be talking more about at Wrocław in Poland in April. It's called Literal, and it's a really, really fascinating project. So I'm just going to tease more of the details of our talk there. The name of our talk is going to be Ruby has always had types. And for those of you who don't know, Ruby has always had types, and Literal sort of finishes the type system that has existed in Ruby for a long time. And the way that it does that, and the way that Ruby has types, is that there is a runtime type system. So what does that mean? What can you do with that? How is that different from a statically typed language, a compile time typing system? There's a lot of interesting stuff to stay there, and I'll just leave you tease. Come check it out at Wrocław RB in April, or just go check out literal.fun, read the documentation. That is a really excellent library. And then a newer library that is still sort of in beta, but is really exciting, is called QuickDraw. And that is a testing framework and test runner. So basically a direct competitor to RSpec and Minitest. And the big selling point is that it is built from the ground up specifically for our modern multi-core environment. And so it has a highly optimized handwritten test runner that distributes your tests as efficiently as possible across all of your computer's cores. And so it runs at, if you have like a 10-core machine, about 10 times faster than the equivalent in RSpec. And it is just incredibly fast. It is so cool. It has a watch mode, and you can just like leave it on, and you're just saving your files, and it just finishes. I am working on a SQLite parser, and I have a test suite currently at about 35,000 assertions, and I just leave it mode, and it runs in like on my M1 Mac in like 700 milliseconds. So I just am refactoring away and letting it sit in watch mode. So really, really awesome projects. I've really enjoyed working on them with him and using them in my work for the last few. So I definitely recommend people check those out.
Very cool. Yeah, a lot of stuff to check out there. Well, thanks for coming. I'm not gonna talk about the Super Bowl because I like both teams. I'm trying to decide which way I want to go. So anyway, thanks for coming, Stephen.
Thank you so much for having me. It was a blast to talk about all this stuff with y'all.
Yep, absolutely. Well, let's wrap up. Until next time, folks, Max out.